Hello students, welcome you all into the Jaswal Edu Maths. Today we are going to do the most important topic of mathematics, the complex number. Okay, so when we talk about the complex number, how it looks like. Suppose you have the number 2 plus root 6. So can you solve this? So you can see that it is an irrational number. Okay, so it is an irrational number. All right, so we call it a number. So it is, we can say that it is a real number also. Okay, a real number. But one thing, what about 2 plus root minus 6? What would it be? Is it a real number? So we can say that no, it is not a real number. So we represent, or our mathematician gave this number name complex number. How? You can write it as 2 plus root 6 into root minus 1, and this root minus 1 can be written as iota. Okay, and the correct form is 2 plus iota root 6. So it is a complex number. Okay, here you see 2 and 6, 2 is called the real part. Okay, the real part, and this term is called imaginary part. So that means, what is root minus 1? It is an imaginary number, and this is represented as iota. All right, I hope you have understood this. Now we are moving to another topic. So what is complex number? You have understood. Now we are moving to the presentation. The general form is z equal to a plus iota b. What? Z equal to, let it dry. So z equal to a plus iota b is the general form, where a and b are, we can say that a and b are real number. All right, they are a real number. So value of root iota is root minus 1. What is the value of I square? It will be minus 1. What would be I cube? It would be I square into I, means what is the value of I square? It is minus 1, and iota it can be written as, that means I cube equal to minus iota. What is the value of I4? It is I square into I square, that means minus 1 into minus 1, because I square answer minus 1, I square is also minus 1, then minus 1 plus 1. In this way we can say that I is equal to root minus 1. Okay, I square is minus 1, I cube is minus iota, and I raised to power 4 is what? 1. What can you say about I raised to power 4 times of n? Okay, it's the multiple of 4, so it would be again 1. What would be if I raised to power 4n plus 1? So it can be I raised to power 4n into I raised to power 1, like I raised to power 4n value is 1, so it would be iota. What about I raised to power 4n plus 2? So it can be written as I raised to power 4n into I raised to power 2, means I raised to power 4n equal to 1, and I square, and what is the value of I square is minus 1. In this way you can say that I raised to power 4n plus, the 4n is 1, I raised to power 4n plus 1 is what? Iota. I raised to power 4n plus 2 is minus iota. I raised to power 4n plus 3. What do you think? So let us solve. 4n plus 3 is actually I raised to power 4n into I raised to power 3. So I raised to power 4n equal to 1, and what is the value of I raised to power 3 is minus iota, so it would be minus iota. Oh no, I think so it is minus 1. This one is wrong, minus 1, and this one is minus iota. All right, so we would use these properties in the equation. So now imaginary part, real part. Okay, should we do the real question? Yeah. Okay, the question is 1 plus I raised to power 4 1 plus 1 upon iota raised to power 4. Okay, so you need to find the answer of this question. So what would you do? You have to do 1 plus iota raised to power 4, and what is 1 plus 1 by iota is actually minus iota. Why? So here you can solve 1 by iota equal to 1 by iota times iota upon iota. You can say like this, because you have to iota in the denominator, it is the imaginary number, so you have to eliminate it. So how would you, sorry, not eliminate, you have to convert it into the real form. So you actually do this, that means rationalize this way. So you would get I upon I square, the I upon I square is minus 1, you would get here minus iota in this way. So you can write 1 upon I, and instead of 1 upon I you can write here minus iota raised to power 4. So what you can do, 1 plus iota, 1 minus iota, you can write here 1 square minus iota square, and that would be power 4. 1 minus what is iota square is minus 1, you would get 1 power 4, and 2 raised to power 4 is 16. Very easy question. But now algebra of the complex number, how would you add two complex numbers? Suppose z1 equal to a plus iota b and z2 equal to c plus iota d. Okay, how would you add these two? So z1 plus z2 equal to real part will be added to the real part, and imaginary part will be added to the imaginary part. The real part is this a plus c. Okay, a plus c like this. Real part will be added by real part, plus imaginary part will be added by imaginary, means iota b plus iota d. You can take iota common, it would be iota b plus d. Same, you can subtract it also like this. A real part will be subtracted by a real part, that means the a and c are the real part here, minus iota, that means and the imaginary part will be subtracted by imaginary part. Here you see that when you subtract these two, so you get here iota plus iota, okay, outside common, b minus d. All right, can you divide it also? Yes, we can divide z1 upon z2 also. We can do a plus iota b upon c plus iota d. Here should not be equal to 0, yeah, because you know that 0 can be written as 0 plus iota 0. Yes, so this c plus z2 should not be equal to 0 here. Okay, so we can divide it also. So we can do the conjugate part. We need to rationalize it. How would you rationalize? Do you know? So you can further solve it like this. Denominator cannot take the imaginary part, so we have to convert this into real. How? You have to rationalize this with the conjugate of denominator. What is denominator here? C plus iota b. What is the conjugate of this? The conjugate of this c plus iota b is c minus iota d. All right, upon c minus iota d. So you get here a plus iota b, a c minus iota d, okay, upon c square minus iota d whole square. Iota square is minus 1, so here would get iota square plus d square like this. All right, so in this way you can also divide the complex number, add, subtract, divide, multiply. Yes, I forgot to multiply. You can also multiply to z1 into z2, like a plus iota b multiplied by c plus iota d. How would you multiply it? ac plus iota ad plus iota b c plus iota into iota square bd. As you know, you can take common here iota ad plus bc, but you know here what is I square? I square is minus 1. You can put the value of I square to get iota square bd. Okay, so it would be ac minus bd. All right, plus iota of AD plus BC in this way. Is it right or wrong? I think, yeah, it is right. So in this way you can also do what? The product of the two complex number also. So what about the properties, the combinative, associative? Here in addition, Z1 plus Z2 equal to Z2 plus Z1. You know what is Z1 A plus iota B, Z2 C plus iota D. Okay, combinative property here. We also can talk about Z2 Z3. Okay, so this is what? Z1 plus Z2 plus Z3. It is actually associative property where Z1, Z2, Z3 are three complex numbers. Okay, and also the additive identity. Yes, we can. So what is this? Yes, 0 is the additive identity. Sorry, Z1. So 0 is the additive identity because 0 can be written as 0 plus 0 iota. Okay, iota 0. All right. Now, so here we have in product, same like product, Z1 into Z2 equal to Z1 into Z2 equal to Z2 into Z1. Combinative property hold Z1, Z2, Z3. Okay, Z1, Z2, Z3 like this. Associative property hold, you know that Z1, where Z1, Z2 or Z3 are the three complex number. Added inverse. What about inverse? Z1 into Z2. If Z1 equal to Z2 equal to 1 equal to Z2 into Z1, so you can say that Z1 and Z2 are multiplicative inverse of each other. Yeah. Yes. So in this way you can say that Z1 equal to 1 by, the multiplicative inverse of Z1 is 1 by Z2, or multiplicative inverse of Z2 is 1 by Z1. So multiplicative identity, I think 1. Is there multiplicative identity or not? Anyways, I have a multiplicative inverse associative property. Yes. Let's do the one question. The multiplicative inverse of Z equal to 4 minus multiplicative inverse of Z is what given? It is given that Z equal to 4 minus 3 iota is Z dash. Okay, it is Z dash is the multiplicative inverse of 4 minus 3 iota. You need to find what? Real greatest integer real. Okay, Z dash. This question mark where this represent greatest integer function. Greatest integer function. Okay, so we have the information of Z dash. What is Z dash? Is the multiplicative inverse of Z equal to 4 minus 3 iota. So multiplicative inverse of Z is 1 upon Z. All right, you know this. Okay, so Z dash equal to 1 by Z, that means 1 upon 4 minus 3 iota. Rationalize with the conjugate of denominator. What is this? 4 plus 3 iota upon 4 plus 3 iota. All right, you will get 4 plus 3 iota upon 4, a minus b, a plus b, a square minus b square, 4 square minus 16 minus, okay, iota square. So iota square 3 square, 16 plus 9, iota square is minus 1, that's why. So it get here 4 upon 25 plus 3 upon 25 iota. Yes, this one, the real part is the 4 upon 25, imaginary part is 3 upon 25. Since since we need to get what? Real Z. Okay, so we need to find the value of real Z dash. So what the real part here? 4 upon 25. Okay, this one. So we need to 4 upon 25. the greatest integer function. Okay, so here how would you solve first? This is very important. So you have to tell that this number 4.25 lies between two integers, and the integers are 0 and 1. Okay, this is the formation of greatest integer function. So what value would you take? The value would be 0, the greatest integer. Okay, so this is the presentation, and you have to take the value of the you can say that the lower integer. Okay, lower integer, since it lies between 0 and 1. Okay, so whenever you take the greatest integer function, you always prefer to take what? The lower value, the least value, least integral value, and the 0 is the least integral value in this. So we are not taking 1 as answer because 1 is not included here. Okay, 0 is the answer. Now moving to many. Okay, division of the complex number. Yes, we have done this. Can we do one question with z1 upon z2? Do you want to do one question? 2 plus 3 iota upon 1 plus 2 iota. Again, yes, division is possible, but you need to represent it like this. You have to what? The conjugate. We have to make the multiply and divide by the conjugate of the denominator, which is what? 1 minus 2 iota upon 1 minus 2 iota here, like this. Okay, so when you multiply, so you'd get here 2 1s are 2 minus 4 iota plus 3 iota minus plus minus 6 iota square upon, this is 1 a minus b, a plus b, so 1 square minus 2 square iota square. All right, so we'll get here, and iota square is minus 1, so 2 plus 6 8, minus 4 iota plus 3 iota, it is minus iota upon what would you get here? 1 minus